Hey, it's Mr. Veve, and this lesson is on types of solutions. So let's get into our first key concept here. Materials move across membranes because of concentration differences. So we've already learned about a concentration gradient and how that drives whether water or solute moves back and forth across a membrane. Remember, movement of solute is called diffusion, and movement of water is called osmosis. So let's look at three different types of solutions, and first we're going to discover what a solution is. So a solution is a solute that dissolves in a solvent to form a solution. So in the picture here you can see that the Kool-Aid looking stuff there is the solution, and in this case, if it was Kool-Aid, the solute would be the Kool-Aid powder and the solvent would be water. Water in most cases is the solvent in almost all solutions that we're going to look at today. So the three types of solutions we're going to start with are isotonic. Okay, so iso means same, tonic means strength. So this is same strength. A solution is said to be isotonic if the concentration of solute outside the cell and inside the cell is equal. So you can see there in the picture that we have an equal number of those green particles, the solute, inside and outside the cell. So both inside and outside is the same strength. So let's look at what that we see a red blood cell here, and isotonic would mean equal amounts of water are entering and exiting the cell. So the size of that cell is going to stay constant over a certain period of time. So water moving in, water moving out, no problems there. So let's talk about a hypertonic. Hyper is more, tonic is strength. So this is a more concentrated solution here. So a solution is hypertonic if it has more solute per solvent than a cell. So as you can see on the outside of the cell here, there's a lot of these green particles and fewer of them on the inside of the cell. So think of those maybe as salt or something like that. The saltiness on the outside is a lot more than the inside of the cell. So what does that do to the cell? So if the solution on the outside of the cell is hypertonic, it's high concentration, more water is going to want to exit the cell, and that causes the cell to shrivel up. The water is exiting that cell and trying to dilute that hypertonic solution on the outside to make both the inside and the outside of the cell equal. All right, so that's what's going to happen in a hypertonic solution when you put a cell in there. So now the last one is hypotonic, that is less strength. So a solution is hypotonic if it has fewer solute than a cell. So you see there in the picture we've got a tiny amount of solute on the outside with a lot more on the inside. So what do you think is going to happen here? Well, if you have a cell put in a hypotonic solution, there is more solute in the cell than there is outside. So therefore, water is going to want to rush into the cell to make those solutions equal. That's going to actually cause the cell to swell or even burst in some cases, and we'll look at that in just a minute. So if we look at three different types of solutions here, hypo, hyper, and isotonic, and their effects on animal and plant cells. Let's go from left to right here, starting with the top. So if you have a cell and you place it in a hypotonic solution, water is going to rush into the cell and cause it to lyse, which means explode. Okay? If you have an isotonic solution and you put an animal cell in there, it's going to be a normal in and out of water. So everything's fine, water's going to freely go in and out, nothing's going to happen to the cell. That's normal. If you put an animal cell in a hypertonic solution, meaning there's a lot of solute on the outside, water is going to end up leaving the cell to dilute that solution on the outside. So therefore, the cell is going to shrink up or become shriveled. Now, the normal conditions for an animal cell is it wants to be in an isotonic solution. Plant cells are a little bit different. So plant cells, when they're in a hypotonic solution, they get filled up with water, and they don't actually burst. The cell wall actually holds it pretty well, and there's an increase in what's called turgor pressure. So the cell is what's called turgid, and that's normal for the cell. The more turgor pressure, meaning the more the cell is full of water and the more expanded the cell walls are, the better it can reach for sunlight or things like that. If you put a plant cell in an isotonic solution, you're going to have water moving in and out freely. You're not going to hold on to as much water as the plant wants to, and so we would call that a flaccid cell. So that is not ideal for the plant. That's what plants look like when they begin to wilt just a little bit. Finally, for plant cells, if you put them in a hypertonic solution, well, of course, that water is going to rush out, and it's not going to what we call shrivel, it's going to plasmolyze. Same basic principle as shriveling. It's going to have far less water on the inside, and it's basically going to shrivel, but that's called plasmolysis in plant cells. So finally here I have a little picture here for you of a blood cell going through lysis. So those blood cells there are actually put into a hypotonic solution. Water's rushing into the cells, causing them to explode. And that's actually what it looks like under a microscope. And ignore the fact that distilled water is misspelled on the bottom left.